Okay, so now this last bit on multi-step reactions. Multi-step reactions are reactions where one reaction occurs and a product from the first reaction is used in a second reaction to create a product. Now, multi-step reactions can have many steps. This example we're going to look at has 2, but you can have a multi-step reaction that has 3 or 4 steps where the product from the previous step is used as a reactant in the next step. And we'll show how that works in this example. So 50 grams of methane is reacted with 100 grams of dioxygen in a combustion reaction. So this is the reaction we looked at earlier. So then the CO2 is used in a reaction with sodium hydroxide to create sodium bicarbonate. So the first reaction is 75% efficient, second reaction is 87% efficient. How many grams of sodium bicarbonate could be made by this series of reactions? So if we look at just the first reaction, we have a very simple limiting reactant problem using a percent yield. So let's focus on that part first. And we need to determine which product from the first equation is a reactant in the second equation, because that way we know which product to find the theoretical yield for. In this case, carbon dioxide is used in the second step and is created in the first step. So our carbon dioxide is the product that we need to be looking at in the first reaction. So we'll find the limiting reactant and determine how much CO2 can be made by the first reaction. Hopefully by now you guys are feeling pretty comfortable with that. So we will go through some stoich, plug in our reactant, use our mole-to-mole ratio, use molar mass, and plug in our percent yield here at the end, 0.75 times our theoretical yield. So we can make 102.83 grams of CO2 from the methane. Our oxygen, which is 100 grams, can be used to make 68.77 grams of oxygen times 0.75 means we can make about 51.57 grams of oxygen. So it's about half as much. And so because of that, we are only going to consider the amount of product made by the oxygen. So in the second reaction, there's 51.57 grams of carbon dioxide available. That means our third step is to calculate how much sodium bicarbonate can be formed from the carbon dioxide. Naturally, we're going to incorporate our percent yield like we always do. So, in this example, we'll take the starting amount of carbon dioxide, which is actually the amount of reactant in the first step, and we'll plug that in. So we have 51.57 grams of CO2, and then grams to moles, mole to mole, moles to grams. We get 98.45 as our theoretical yield. We'll multiply by our percent yield, and that tells us we're actually going to end up with about 73.84 grams of sodium bicarbonate. And that is the conclusion of our multi-step reaction. So pretty straightforward. You just need to treat each reaction individually and solve it the way you normally would, and then use the shared product to start as a reactant of the next reaction. You have a worksheet with 5 practice problems for percent yield and multi-step reactions. That will be due on Friday. Later this week, I will be posting a stoichiometry review. We will have a short stoichiometry test quiz situation next Monday, but I think it will probably be a little less rigorous than your last test, just because this was kind of a short unit. So anyway, love you guys. Let me know if you have questions, and I will talk to you soon.